Okay, so we're going to talk about the around the world for a minute. So the two questions that you guys had the most confusing time with were number 1 and number 8. So I want to go through those really quickly. So number 1 says R is bounded by y equals x plus 3 and the function y equals e to the x plus 1. Find the area of R. Okay, so the first thing you always want to do with these is either graph it out by hand or by calculator, depending on which one you are allowed to use. So for the first one, this is calculator active. So I'm going to type in x plus 3 and e to the x plus 1 because I want to see exactly what this region looks like. Okay, and I want to draw it out. Okay, so we get kind of like a crescent shape. So I'm going to have my e to the x plus 1 is this guy. And then I'm going to have my y equals x plus 3 is this guy. And the region in between them is going to be this little piece right here. Okay, now the key with this is that because we're finding an area between two curves, our intersection points are going to be our limits of integration. Okay, so we need to figure out what those limits of integration are actually going to be. So I'm going to do second trace, go down to intersect, and I want to do first curve, second curve, and I actually want to make a pretty accurate guess because there are two intersection points here. I don't want to accidentally choose the wrong one. So my first intersection point is negative 1.84. Okay, that's this one right here. And then the top one, second trace, intersect, first curve, second curve. And then I want to actually go up to this intersection, click enter, and I should get 1.15 if we're rounding as my upper limit of integration. Okay, now remember that when we integrate, we are finding the area under the curve. Okay, so if we're trying to find this area here, what we want to do is we want to take the upper one. We want to find the area under that curve. That's going to include like all of this stuff here. And we want to subtract off the area under the bottom curve, which is going to take away all the extra stuff that's underneath, just leaving this shaded region right here. Okay, so we're going to have x plus 3 minus e to the x plus 1 dx. And obviously, you guys could easily combine like terms. This is an easy function to integrate. You could do that. It would be a little annoying with these decimals in our upper and lower bounds. But it's definitely possible. This is calculator active, so let's make this as easy as possible. So what I'm going to do is I'm going to type in my difference, my function difference at the top, plus 1, okay? And I want that, and I'm going to delete this other one. I want that to be the thing that I'm integrating, right? Because that's what I'm integrating right here. So I'm going to do second trace, go down to number 7, click enter, little integral sign. It's going to draw the difference function here. And then it's going to ask for my lower limit. I want negative 1.84. My upper limit is going to be 1.15. And this is going to give me about 1.95 units squared. Okay, and this will be my final answer. And I think this maps to, I know that it maps to 1. I feel like it's number 3, but I don't remember. Okay, so that's number 1. And we did a lot of that on the calculator because it was calculator active. We're trying to make things as efficient as possible. Now, let me remove this stupid ladybug so you guys can see. Okay. So hopefully you were able to see most of that. I'm sorry. So then number 8, we have, it gives us the function y equals 2x minus 4. It tells you the region is between this, the x-axis, and it goes from 0, x equals 0, to x equals 3. and it wants you to find the area of R. This is like a shorthand version of the question, sorry. And this one gives you the picture. So it is something like this, where it has 3 here, and it wants you to find the area of this shaded region right here. Okay, so the tempting thing to do, and I know that some of you did this, is just to straight up integrate from 0 to 3. Okay, this is wrong. The reason why this is wrong is because we have this region down here, which is going to give us a negative value. Okay, it's going to give us a negative area. So to actually find the area underneath this curve, or between this curve and the x-axis, we're going to need to split it into 2 pieces, a negative piece and a positive piece, so that, so negative piece, positive, so that we can force the negative part to be positive. We force the negative part to be positive by writing it as absolute value. Okay, so we're going to have the absolute value from here to whatever that point is. So from 0 to something, we're still using our same function. Okay, and we're going to add on the integral from whatever that middle point is to 3 of the same function. And this will be positive, so we don't have to force it to be positive using the absolute value. Now, we need to figure out what this middle point is right here. So in order to do that, it happens to be the x-intercept. We find the x-intercept by setting y equal to 0. Oh, that was a minus. Hey, look, I got white out. So now my notes will be prettier than they were. So -4. So to figure it out, we want to add 4 to both sides. Divide by 2. So x is equal to, whoops. Also, I'm trying new whiteout because it was cheaper. Okay, so 2 is my point right here. Okay, so this means that my upper limit for my first integral is 2, my lower limit for my second integral is 2. So I'm going to go ahead and integrate this. I believe this was not calculator active. So I am going to actually solve this all out. So for the first integral, we would have the absolute value of the integral of 2x is x squared minus 4x. And this one's going to be from 0 to 2. And we're still taking the absolute value of that. And then we're going to add on the same thing. Excuse me, sorry. But from 2 to 3. Okay, so we're going to do the first one. So when we sub in 2, we'll get 4, and then we would have -8. We want to subtract off 0 subbed in, which of course is just going to give you 0 as a whole for that term. Okay, and then we would want to add on, I guess I can put these in square brackets to indicate that they're separate pieces. I would have 3 squared minus 4 times 3, and then minus the same thing right here, 4 minus 8, because I'm subbing in 2. Okay, so I'm going to have 4 minus 8, which is -4. Oh, and I forgot, I still have my absolute value around everything here. Okay, so I have the absolute value of -4 because we're subtracting 0 from it. I guess I don't need, the square bracket. So I have the absolute value of -4 plus, let's see, over here we're going to have 9 minus 12 minus -4. So this is going to end up being +4. 9 minus 12 is -3. And then minus -4 is +4. -3 plus 4 is 1, so I'm going to have 4 plus 1, which is 5 units squared. And I honestly don't remember which one this mapped to. Oh, hold on. Around the world. It maps to question number 4. Okay. So here we go. Okay. So that is all for number 1 and number 8. I hope that that makes more sense to you now. I did get a significant amount of questions about this one, why you can't do this. And it's just because you have to remember that below the x-axis, you have a negative area value. Okay, well, I'll post these solutions, and I miss you guys very much. I hope you're doing okay. I'll talk to you later. Bye.